Today I am taking one problem from work, energy and power. So let us see this question. So work, energy and power, and this question was asked in JEE Main. Okay, it was asked in JEE exam, JEE Main. So in 24th June, okay, 2022. So in 2022 it was asked in JEE Main exam. Okay, so this is very important question. So let us see this question. See, question says a ball of mass 100 gram is dropped from a height 10 centimeter on a platform fixed at the top of a vertical spring. The ball stays on the platform and the platform is depressed by a distance h by 2. The spring constant is. So we need to find spring constant. Spring constant usually we denote by K. So spring constant K, we need to find value of K. So basically if we draw a diagram for this question, see, ball is there and it is falling down in a platform that consists of spring. Okay, see, this is spring, this is platform. So which is spring is fixed here on the ground, you can say spring is fixed here, and this is platform where this ball gonna drop. Okay, ball gonna hit. So this ball is at height h from the platform. This is your platform. Okay, don't get confused, this is not your platform, this one is your platform. Okay, you should not get confused. So this h value is also given, h value clearly 10 centimeter. So 10 centimeter, if you convert, you will get 10 into 10 power minus 2 meter. Similarly 100 gram, so mass of the ball is 100 gram. So 100 gram means 100 gram means directly you can write 1 into 10 power minus 1 kg, that is 0.1 kg. Okay, now see, after this ball hit, I'll draw it here, see, as this ball hit this platform, this spring get compressed, compressed. Let me draw it again. See here, this is your platform, sorry, this is your base where spring is attached, and this platform got compressed, this spring got compressed, by how much? H by 2. So compression usually we denote by x. So compression, if I denote by x, it is h by 2. Here what is x? Here x is compression, in spring, compression. Okay, x is compression or change in length of spring. Here x is change in length of spring. Now see, as soon as this, what is happening here? So okay, this is the question from work, energy and power, and it was asked in JEE 2022. It is very important question. See, this ball, it has, if I take this as reference frame, then it has potential energy mgh, this height is h, so potential energy mgh is stored in this ball. Now it fall and it hit on this platform which is connected to the spring and attached to the fixed point here. Now see, if you see here, after this ball hit this platform, the spring get compressed, and compression is h by 2, means h is 10 centimeters, so compression h by 2 means 5 centimeters. So there is change in length of spring, means spring length is decreased by 5 centimeters. So what happened to that potential energy? This potential energy, its value is decreased because the ball height is now decreased. That change in potential energy, whatever decrement in potential energy, is converted into spring potential energy. Okay, not kinetic energy, initially kinetic, but after hitting this platform, finally it come to the rest. So but spring is compressed, so spring potential energy, and spring potential energy, here potential, gravitational potential energy, some portion of gravitational potential energy is converted into spring potential energy. So spring potential energy, if I denote by U, spring potential energy, its formula is half kx square. Here work done by gravitational force, you can say work done by gravitational force on this ball, or you can say work done by the weight of this ball, is stored in the form of spring potential energy. Because see here, whatever work is done by the gravitational force, you can say that work done is stored in the form of spring potential energy. Okay, now if you see, here, now how to solve this question, we can use energy conservation, principle, in order to solve this problem. Energy conservation principle, we can use energy conservation principle to solve this problem. Energy conservation principle can be used to solve this problem. This is somewhat mediocre type of problem. Okay, now let us see solution part. Now see, let me find at first gravitational potential energy. I will take this as reference, this as reference, initial platform, this as reference I will take. So if I take this as reference, if I take this as reference, now final position of ball, if you see, it is decreased. So see, if I will take this as 0, okay, so height is h here. So initial okay, initial u here, it is representing energy, okay, potential energy. Basically in general in physics we denote potential energy by u. So initial potential energy, it is mgh, that is gravitational potential energy, because initially there is no energy in spring, because spring was not compressed initially, okay. When spring get compressed or elongate, then it has capacity to do work. So in that case we can say that potential energy is stored in the spring. Catapult also you can take it as example. So in the spring, say whenever the spring is compressed, if you release, it has tendency to do work. So it means that potential energy is stored in the spring, but initially it is not compressed. So here spring potential energy is not there, but gravitational potential energy is there. This as reference. So this is your height. So mgh you will get, how much you will get, mass is 0.1 kg, because 1 into 10 power minus 1 means 0.1 kg. Gravity value, acceleration due to gravity, you can take it as 10. So h is given as 10 centimeter. 10 centimeter means 0.1 meter. So you will be getting 0.1 joule, okay, SI value 0.1 joule. So initial total energy, you have to see. So initial total energy is 0.1 joule, okay, initial total. This is initial total, okay, for this is initial, this is initially, okay, initially. So we are going to use energy conservation principle. So see, if you use energy conservation principle, now spring potential energy, it is given by half kx square. So a half k value we need to find, which is spring constant. X square is compression, which is h by 2. X was h by 2, it's given in the question. So h by 2 means 10 centimeter divided by 2. 10 centimeter divided by 2, that is 5 centimeter. So 5 centimeter means 5 into 10 power minus 2 meter. So if I write here, I'll get 25 into 10 power minus 4, okay, meter square I'll get. So spring potential energy. Now let us see gravitational potential energy. If you see gravitational potential energy, see this we have taken as reference, and now the ball position is below this, okay, it's below this. So gravitational potential energy will be in negative, because this is reference, means here gravitational potential energy is 0, here it was maximum. Now ball is here, means it is compressed by h by 2, means gravitational potential energy, it will be mg into this, how much it is compressed, s by 2. This is 0, so it will be minus s by 2. So it is decreased. So what you will get, since this is the reference point where gravitational potential energy is 0, above this gravitational potential energy will be positive, below this it will be negative, and below, how much below, it is h by 2 below this. So you will get gravitational potential energy. If I write as ug as shortcut, I will get minus mgh, okay. You can write here, you can eliminate this negative sign while putting the value. That minus sign comes automatically, as I have explained you just before, okay. So mass is 0.1, g is 10, height is means it is decreased. So again here 5 into 10 power minus 2. So you will be getting 5 into 10 power minus 2. Now total means energy conservation will use according to okay, according to energy conservation principle, energy conservation principle, total energy. So initial total energy is equal to final total energy. So this implies, what is initial total energy? Initial total energy was, if you see, initial total energy, it is 0.1 joule. So 0.1 joule means 0.1 is equal to final is spring potential energy, this value, and gravitational potential energy, this value, which is negative, okay. This value is negative because it is below the reference point. Now 0.1, now final it is half k into 25 into 10 power minus 4 minus 5 into 10 power minus 2. So now only solving part is left. So what you will get, 0.1 plus, so 0.05 you can write, because this 5 into 10 power minus 2 is 0.05. When it comes to LHS, it will become plus 0.05. So here what you will get, half k 25 into 10 power minus 4. So this is 0.15, 0.15 into 2 means 0.3. So 0.3, 0.3 into 10 power 4, 10 power 4 divide by 25 is the value of spring constant. This implies k is equal to how much? See, 3 means 25 4 is 100. So k value you will get, if I solve it here, k value how much you will get? See, 10, if I give to 0.3, it will be 3 into 1000 divided by 25. 25 4 is 100. So 40 is a 1000. So 43 is a 120. So your answer is 120. 120, and SI unit is Newton per meter. Okay, how you will know SI unit? Because F equal to kx minus kx, you know this. X unit is, this is compression or elongation, change in length. So the F is Newton, so K will be Newton divided by meter, that is Newton per meter. So this is your correct answer. Okay, if you do this much, then you will get max, total max in your board exam, and if you have to solve quickly in JEE exam. So I hope you will do it. Okay, so you will get allocated marks, okay, in whatever competitive exam. Okay, thank you.